Hello, everyone, and welcome to the Geek Nighter podcast. I am back with another episode. Distributed systems are hard. I mean, even just talking about them theoretically itself is hard. But running a distributed system in a production environment and serving real customers is really a pain. But it's not a pain if you have good insights, good practices, good processes to follow. And to learn about all those insights and practices and processes, I have Mayank Shrivastava with me. Mayank is currently working at StarTree, the company behind Pinot. And so welcome, Mayank, to this episode. And thanks a lot for joining us and being ready for sharing all those insights. So let's start with a little bit of introduction.
Yeah, hey, Keval, yeah, definitely. Thanks for inviting me. I think this will be a great talk. I'm really excited to share my experiences. Let me introduce myself. My name is Mayank, as you already mentioned. I am one of the original team members that helped build Apache Pinot at LinkedIn. And, right now we and a bunch of, the original folks who started the project at LinkedIn have formed this company, and I am part of that company right now.
Awesome. So as our viewers can actually see that, there's a lot of experience there, right? Like Apache Pinot itself is a huge system, hosting it like tons of data and, at serving millisecond or even sub-millisecond latencies at huge data sets itself is a huge problem. And Pinot solves it gracefully. And so let's start with our, journey into distributed systems. And more importantly, how do we run distributed systems like a pro? Great. So let me just cover like a brief agenda, what we are going to talk about today. So when it comes to distributed systems, it's not just about, developing distributed systems. That is one part of it. But then you have to have some process to get it released into production, right? You need to test it. And then once it is in production, you need some observability and some monitoring in place to make sure everything is correct and you're not impacting the customer. And then once that is done, what happens if things go wrong, right? You need to have those processes. So there is like fault tolerance and all those things that come into picture. So we are going to cover all these 4 sections into depth, and I'll try to ask all those interesting questions to Mayank. So Mayank, let's start with the basics. Like what kind of systems are we talking about here?
Yeah, so that's good to kind of set as context in terms of what we're going to talk about. Whenever you write software, it ends up either being a library, goes into an enterprise product, a microservice, or a stateless system, or one of the distributor systems, right? So these are some of the vehicles that how your code sees the light of the day, and a lot of what we might end up discussing today is applicable across the board. But I think today we want to kind of like focus a little bit more in depth in the stateful systems, I would say. Mm-hmm. And even in stateful systems, I personally categorize them as 2 buckets. One is where the workload or the work done per query is kind of constant or fixed. Your typical key value stores come up in that bucket. But then there's systems where the workload varies as the query changes or the data size changes and so on. And those systems are slightly, a little bit more complex than the other ones too.
Yeah.
So I'll try to kind of like take the most complex case and answer your questions based on that. And hopefully it covers the others as well.
Awesome. Yeah, that sounds great. I mean, stateful systems, as you mentioned, are hard because there is state. You are changing something. And let's start with, the development part of it. So what are some practices or some processes that we should follow to make sure we are developing the distributed systems in a right way?
Yeah, definitely. I think the very first thing is, you need to have like a solid design, which is and an architecture for the system, which is, highly scalable, available, and resilient to faults and so on, right? Yeah. So that definitely takes a lot of effort and expertise in the area, as well as experience of building past systems to kind of not, learn or rather learn from your mistakes in the past or your experiences in the past, and like avoid certain pitfalls, right?
Yeah.
So that's definitely it. In terms of the development itself, you want to be wary of design reviews, right from the top level design all the way up until the lowest level algorithm or lowest level reads and writes or IOs that you might be doing, right? Because if you are building a system which is very performance and latency critical, these things, every step in the stack matters, right?
Makes sense.
So it's always good to have that like solid foundation.
Yes, that makes sense. Let's just to add more clarity to it, what do we mean by solid scalable design, and what are the common bottlenecks that you have seen in your experience when it comes to scalability?
So solid scalable design means if your software should be able to scale vertically if you are sizing up a single node, as well as horizontally if you are adding more and more nodes, right? And this is something that is, again, like I mentioned earlier, is a function of not just the low-level optimizations, but also the high-level architecture, high-level system design that you have done. Let's take a very concrete example where I work on Pinot, so I can use an example from there. Is when a query comes into Pinot, there's a broker which feeds the query, and then there is servers which are hosting the data shards, right? And the query can fan out to n number of servers in the cluster if you have enough time, right? But we know that this is not a scalable architecture for a single stage scatter gather kind of a scenario, because what ends up happening is if you have, let's say, 10 servers and you're getting certain performance, you add another 10 servers, your performance may not improve by 2x, right? Why that happens is there's a bottleneck that there is a single stage in the broker which is just gathering all the results and doing all its work, right? So that's one very typical example, right? Things like this you kind of have to be very, very wary of when designing the system. Bottlenecks, I would say that there is most, in my experience, data intensive systems tend to be memory and IO intensive, unless you're doing a whole lot of number crunching in the CPU. So you want to kind of be very wary of how you're accessing disk, how you're laying out the data in the disk, so that you don't keep on jumping and doing like n number of seeks on your disk. Right. If you can write some code which enables vectorized computation, those kind of things also help, right? Avoiding garbage collection, not trying to allocate memory which is unnecessary, or efficient use of memory and resources, right?
I think that makes sense, and that example from Pinot also makes sense, because it doesn't matter how many servers you have to scatter that processing. Ultimately, it's going to come at one broker, which is which might become the bottleneck in terms of memory.
We're changing that, by the way. We are moving to a multi-stage query engine. But yes, that was just an example.
Okay, interesting. That's very interesting, and it's like from real life architecture that Pinot works, right? So, great. What are some other steps to follow when we are developing a distributed system?
Right. So, I mean, the development cycle should have solid design reviews, code reviews, and so on. But beyond that, you want to have safety net to ensure that you are not regressing in terms of the functionality, in terms of performance, and in terms of backward compatibility, right? So solid testing at unit level testing, integration level testing, that's good. But you should also have a staging cluster where you can actually test how your new code or new deployment is interacting with other systems, right? That should not break. Performance benchmarking is another one wherein, with every critical part of the code change, for example, if you're making changes in the way you read or write data, You want to make sure that you are not regressing in performance. So having systems or automation built around catching those early on helps you save a lot of trouble, debugging production issues. Right.
Yeah. I think that makes sense. I just have one question on the performance benchmarking thing, right? I think you mentioned that whenever you change something critical in your system, you want to do this performance benchmarking.
Yeah.
How do we define critical? Like, when do I know that, okay, this is something that requires like performance benchmarking, and how frequently should that be done? Because I guess performance benchmarking itself has some cost to it, right? Like, we cannot do like performance benchmarking, for example, every day. So what is the frequency that
correct
that makes
sense?
So
it's a great question, right? So I think if you have been working on a particular system, you would know what the critical paths are for the read and write, right? A lot of times, are you a read optimized, are you a write optimized system? And if you are in or both optimized, right? So you want to have, but then there will be systems, other parts of the system which are more like peripheral or maybe admin related and so on. So you kind of know for a given any new feature that you're building, is it in the critical path in the system where we want to ensure specific SLA or a contract, right? And that's a guiding factor to that.
Yeah.
And then so again, like it's a mix of people, process, and technology. So process need to be set up to make sure that every commit or a bunch of commits that happen at a periodic level or time cadence get certified for performance, right? And you want to probably that's more around the release certification process. But if somebody is working on or touching how your data is read in from disk or so, it's always good practice to say like, okay, here's I handcraft a benchmark and show how before and after pictures, for example, right? And then how that translates to the end-to-end workload when you run it actually in a production like setup. So those are definitely things to watch out for. And at the end of the day, right, sense. You have to have like safety net at each level, right? Because maybe we are all humans, right? And nobody can write perfect code the first go. Maybe people can, but generally speaking, it's hard. And so,
it's hard,
right. So the best you can do is have protection built in terms of your performance certification clusters or tests and suites, which will kind of pinpoint if you regressed.
Yeah. I think you covered some nice points here. Like when you're working with a distributed system, you know what are the critical paths, right? And then you can use your good judgment to understand that, okay, this is a critical path and I'm changing something on this path. So this might be a good case for a performance benchmarking use case. Right. And the other point was, you cannot avoid failures. It's a distributed system. No one is perfect. We are all humans. So, embracing failures and have those safety nets at each step of your, development life cycle.
Right.
I think that makes sense.
Right.
Great. Yeah. So do you want to add something more there or?
Yeah, I mean, so we're talking about the overall development process end to end, right? So we talked more about some of the best practices, but I think one thing we should also, elaborate a little bit on is the actual development process itself, right? What kind of tool or methodology you want to use. And I don't think I have a perfect answer for that. Some people like use Scrum, some others like, Kanban. And in my opinion, I feel like depending on the project itself, depending on the work in the project, depending on the stage in the life cycle of the project or the product, systems may vary sometimes. Like, for example, I'll give you a concrete example, right? So in Apache Pinot, we work in a lot of areas within the system. There are certain projects which are multi-quarter, for example, right? Which may be like overhauling the entire execution engine, for example. Versus there may be some which are saying, okay, I'm going to add more observability and such. right? So a Scrum-like system where you are very well-defined tasks, and you can actually use that. Whereas if you are in a multi-quarter research mode, you can still use the system. I've seen folks kind of like shying away from, like, okay, I don't want to say that today I'm going to write this benchmark versus tomorrow I'm going to do some paper study and so on. I would say exercise judgment. I think these are more systems to assist the process, as opposed to the tax that everybody needs to pay regardless of whether they're getting an ROI or not. Right. I think, and that's how I see it.
Yeah. I think that makes sense. And each use case might be different, as you mentioned, and one needs to assess like what works best for them. But as general guidelines, I think what we have covered so far is the development part of it. So of course, pay enough attention on designing a good scalable system, and have those testing in place and automation in place to make sure you're testing the right thing, and you're testing regularly and continuously, and you're not shipping any broken or adding regression to your existing system. And then we also talked about having a process in place where you have these safety nets, because failures are bound to happen, and you make that good judgment to see how frequently you should do some kind of testing and what kind of safety nets you want to have. And then at the end process, you can follow Scrum, Kanban, depending on the use case, but there needs to be some process, so the team is doing the right thing. Great. I think with this, you previously mentioned one term called release certification. So let's enter into the next section, which is how to release that whatever you have developed, the system, and how to release those changes in the production in a safe manner. So let's talk about release certification.
Right. Yeah, definitely. I think that's once you've done the development part, you want to make sure that your code sees the light of the day for sure, right? That's why you wrote the code. And you also want to make sure that the code that you deploy now is at least equal, hopefully better than what was running before, right? And one way to kind of like ensure that is to have like a proper certification process for your project or your code. Again, like I think I mentioned this briefly earlier, is you want to make sure that there is no regression in terms of functional performance or any compatibility, right? Because this is you may be your service may be interacting with other services, or may have components internally which may be interacting with each other and get deployed separately from one another. And during that deployment, is the internal compatibility maintained? Is the external compatibility maintained, and so on? Right? So I think typical, I have seen things like, you have like a nightly build, which is kind of ensuring that any active development bugs get caught, but then there should be a release certification, which takes like, okay, now the code, maybe weekly or whatever cadence suits your, project needs. Where you go through a lot more, regressive testing in terms of making sure not only just your part of the system works, but it also works well with other systems it usually ends up talking to in a customer deployment or a user deployment, for example. Right? So certification definitely is like something that we should. These are all things that will, help us cut down, the time we may end up spending in, for example, a 4 a.m. call in production, for example. Right?
Makes sense.
The effort spent here is always to reduce production issues.
Makes sense. And that makes sense. And I think the release certification, kind of should be automated, right? Because you don't want, because you are doing it for speed, that you also release features with speed, but ensuring that the quality is maintained. Just to add one example from my experience, and then you can certify that this is the right example for this case, is that I once made a kind of backward incompatible change to one of the APIs. And then, I added a non-optional field in the contract, and then I created like a pull request. And then there was like a certification, like automation system that started failing my build because it said, okay, you have added a backward incompatible change. So is that a good example for release certification?
Absolutely. Yes, absolutely. I mean, yes, absolutely. Because, and I'm glad your system was, mature enough to catch this before it was deployed, right? Think about a case where it's already deployed and all your, client services that are making calls to your service start failing suddenly. That you definitely do not want that.
Yeah. And that's even more critical when it's a stateful system and you have some events to process and all that. Great. Sounds good. And so we have these safety nets in place. We have release certification, and now we want to go to production or let's say a QA environment. So how do we deploy these, and what are the strategies?
Right. So I would have this entire umbrella as the CI/CD, right? Code being developed continuously, being tested and certified at proper cadence. Once you have a certified release, you also want to automate how it is, sees the light of the day in production, right? Typical things that I've seen is, you may have a dev cluster where it gets deployed and it's being tested on, the interactions with other subsystems, which your service may be talking to, slash staging, they are pretty much more or less the same. I've also seen sometimes if you, for example, are doing like a major overhaul, maybe you change the storage format, for example, to make it better or something like that. Before you go to production, you may want to, shadow the production traffic to see how the code works in a production-like setup. Because typically, while you may mimic the production characteristics of the workload, it's typically expensive as well as not practical to do it at a production scale, right? So the scale testing, so I have seen a pattern where it's like you have a shadow cluster, we deploy the new code, and it's kind of shadowing all the read and writes to this particular cluster, and then you can observe it and monitor it and to make sure that it's able to withstand and it's achieving what you wanted it to achieve. And then you can have Canary. Like Canary is something that I haven't seen work really well with stateful systems because there is to guarantee or to satisfy a read request, there may be multiple players or components involved. Whereas you may be deploying Canary to a subset of it, and you sometimes either it may be too noisy or it may just not catch the issues. But for stateless systems or systems that are well behaved in terms of constant workload kind, this is a good thing to have for sure. And then you can finally promote to production. And again, this is all the more automation you have built around it, the better it is. Let's take an example that you build a new feature, right? And this is a feature that you're not really sure. Well, I mean, you've done your part to make sure, but as a safety net, you may want to kind of have a config for it, saying I only enable it if the config is on, versus I have a kill switch when I can just turn it off dynamically, and I don't need to roll back, for example, right? But if you do need to roll back from an image or a deployment from production, there should be automation around that as well. And more importantly, there's trackability, right? This is very, very important because a person who may be on call may not know or have the context of, was there a new release deployed? Somebody changed a config, and if they did, why did they do it? And those kind of things, right? And having these trackability handy is a very, very, very productive, it's a productivity boost, I would say.
Yeah, I think that makes sense. And again, there were some, very interesting points here. I'm just curious to, talk a little bit more about the Canary deployment that doesn't work very well with stateful system.
Think of it as a request comes in. Let's say it's a read request, right? There are 7 different servers responsible for answering that. They're all doing their part.
Yeah.
And the Canary that was deployed may not even have the data for that particular shard for the query.
Okay.
Right?
Yeah.
And then your code on the other ones would have failed, but you did not cache this, right? So, I mean, these are examples, where I have seen it not be as effective.
Yeah.
But does not mean that there are, I'm pretty sure there are other examples where it is kind of. So you need to find the right balance in terms of the process that you are, going with, or the pattern that you're going with the and the ROI that you're going to get with that, right?
Yeah.
Some things the Canary may be good at is kind of capturing if you are increasing the CPU usage, for example, or garbage collection certainly goes up. So more like system level, right? Or maybe if you broke a functionality, you would definitely cache with that. But more for performance and all, it may or may not.
Yeah.
So you may still want to have a Canary.
Yeah, I think I've also seen it used in a lot of stateless system, stateful system. I think we tried it once, and I think we faced some issues. But yeah, I think that's a good strategy, and to assess what kind of deployment model works for you. Canary is not like a silver bullet; it won't work for everything. There are some downsides to it, and also some limitations. So yeah, I think it makes sense. And then you also talked about something called trackability, that you want to be able to track things very quickly, because when things go wrong, when someone is on call, is not aware of the entire system, and tracking where the problem lies itself is a big challenge. And we might discuss, we are going to discuss some strategies around that, like how to make that on call process and all easier, more manageable. But that I think is a great point. Cool. So I think we talked about the development of the system and what kind of practices we could use, and then we talked about the release pipeline itself and the deployment model. Let's talk about what happens after the deployment is done. So how do we observe a system that it's working fine? What kind of metrics should we consider?
Right. So I think you definitely the next step is to kind of think about observability and operability, supportability, and debuggability, right? All the abilities that you would want to have if things go wrong in production. So it is very good it is a must that a system is, we talked about the system being scalable and available and resilient and so on, but it also needs to be very, very observable, right? And what I mean by that is, if there is something going on, either wrong in the code, or maybe because the workload suddenly changed, because suddenly there's a lot of read requests bursting into the system, or some heavy queries coming in, things like that. We need to be able to quickly find, first of all, be able to observe it, and then once we have a system to observe it, then the next step is to kind of alert on it, monitor it and alert on it, and then kind of have mitigation steps around it, right? Right. So when you're building the software, you want to make sure that you are creating the right set of metrics to emit from the code that will improve the observability of the system, because the person who is building the software may likely not be the person who's going to operate it. So you want to make it easy for the person who's going to operate to observe the system, right, and find issues. And in that, I've seen you typically a lot of the system level metrics, like your CPU memory usage, garbage collection, network, IO, those kind of things are always there. But I think as a developer of a system, you want to also add application level metrics to make it a lot more observable and to be able to pinpoint. For example, if suddenly I see read latency spike, I should be able to figure out whether it is because there were, suddenly a workload change or, something else, for example, right?
Yeah. I think that makes sense. And we talked about like different metrics, and let's talk a little bit more about the application level metrics. So if I talk about Apache Pinot as an example, what would be a good example of an application level metric?
Yeah. So definitely, I think you want to think in terms of the read and the write path, and also your all the things that are happening in the background, which are not necessarily related on the read and write path, and you want to be able to triage an issue just by looking at metrics when an issue happens, right? So more concretely, let's take an example of we have query latency metric, for example, right? And then there is a latency spike. We have latencies that we report, different percentiles from 50 to 75, 90, 95, 99, whatever, right? And then have alerts on the appropriate one based on the use case or the SLA requirement.
Yeah.
And now, once you are seeing that alert, you want to be able to narrow down the problem, right? And to be able to narrow down the problem, we have in Pinot kind of build a lot of metrics. I can go and check, was there a read QPS spike, right? No, maybe there wasn't. Or maybe there was a little bit. What is the work done that's happening, right? How many documents Pinot is scanning during the filter phase, during the aggregation phase, and so on, right? Those kind of things. How many, if the queries, the selectivity of the query, right? The number of groups that a query generates, if it's a SQL group by query, right? And so I can look at the time where the latency spike happened and kind of try to see which one of these metrics is also, showing a spike around that time. Maybe suddenly I see a spike on the number of documents being scanned. Then I would know, either it is a, workload change because there was an expensive query that came in, or there's a burst of queries that came in that is just spiking the number of documents needed to be scanned.
Yeah.
So again, the idea is alert on SLA violation, have the metrics around how you take that and triage to figure out how to mitigate it immediately, like put off the fire, and then take that process back to see if there was a bug in the code or something, and then solve that.
That makes sense. And I think that's also a great interview question. I've seen many companies asking, the SRE engineers or the application support engineers, they ask questions like, okay, let's say I have a website and, suddenly things go wrong. My reads are very slow. How will you debug this? So I think this is a great example that you've given, how step by step and what kind of metrics you can look at just to figure out the root cause of the problem. And for all that, you need good metrics.
Exactly.
You need, good observability, and you need to know, first of all, what are the critical paths for this system, right? Before that, you can't do anything. Great. So we touched upon a little bit on the alerting part. But what I've seen in my experience is that alerting is good, but too much alerting is bad, right? So how do we avoid that noise?
Yes. Yeah, great point, right? I think the alerts are only effective if they are not noisy. The moment they become noisy, people will start muting it, or the real problem actually kind of get buried in the thousands of alerts that you got. So figuring out the right alerting mechanism, also not duplicating. For example, think of it this way, right? Latency spike is the contract. The contract is to maintain a latency under a certain SLA, right?
Yeah.
So you want to alert on that, and that should be good enough if that's all you want to prevent for, right? But this could be because number of documents scanned a lot, or it could also be because that also means that there is a CPU increase, right? Also means that there is probably GC also happening at some point, right? So these are all kind of things. And if you end up setting alerts on these as well as that, right? So for the same issue, you are getting hundreds of alerts except instead of one. So they become less effective. Just, it gets lost in the number of alerts that you get.
Yeah, I think that makes sense. And so you want to have good alerts, and to start with, I think it's best to have alerts only on the SLAs that you're breaking. For example, if you guarantee that, your system is going to, provide like a P99 latency on queries within, let's say, 500 milliseconds, right? So that is a good thing to alert on if your P99 goes, bad. But alerting on something like, let's say, CPU usage going above 90% or something, or memory usage going or shooting up is not a great thing, right? Having those metrics in place is good, but not alerting on them, because they all might be related, and you want just one alert to be there for, the debugging purpose, but not too many that creates a lot of noise and, distract the on-call person. So, and I think that is primary reason why people hate being on call, right? Because there are so many noise and, fake alerts and all those things.
Right. So basically what you want to prevent is, SLA breach, but at the same time, alert on the SLA breach, but also prevention of the SLA breach. Ideally, you want to prevent before the SLA even breaches, right? But it's a fine balance, right? This is the part where you don't want to be too noisy. And you gave the right example, right? My CPU usage typically maybe 40%, but it goes up to 70% suddenly. But if we're not breaching any SLAs and the system can actually handle
it's fine.
Why alert on it? But in certain other cases, it might actually be worthy of alerting. So you kind of have to be, it's a case-by-case basis, I would say. You have to be knowledgeable about the system that you're running to say when it is a problem, when it is not, and when it is worthy of an alert.
Yeah. And correct me if I'm wrong, but this is when the SLOs and SLAs come into picture. So you have those SLAs that is like an agreement with the customer, but you want to have those SLOs which are slightly tighter as compared to SLAs. So you know what is happening if there is something bad going to happen to the customer. So before the customer, right?
Right. You may be running out of disk space, for example. So don't wait until it's 100%. Maybe alert that 80% right, or 60%.
Great. Yeah, I think it makes sense. So yeah, I think we talked about monitoring and being adding observability to the system and also alerting on it. What can we do more to make that life easier?
Right. So the other thing that helped, you're just to finish off the topic of metrics and alerting is to also they should be effective not just to narrow down the issue within your system, but your system may be part of a bigger ecosystem, right? Like your service may just be one of the services, and it may so happen that way upstream somewhere there is an issue because they might feel like, we use the system as the storage, so it must be that one. And a lot of times that happens. So having the metrics being defined in the right way, or to be able to figure out is this particular issue in the overall ecosystem part because of your service? If yes, what is the contribution it is making? If not, then is it upstream, downstream? So that kind of helps you kind of say, hey, well, yeah, I do recognize this, but guess what? The request already came in, several seconds late to me, or when I'm making a call downstream, it's taking longer, right? So that helps that there as well.
Makes sense.
And then the other part of observability is the logs, right? So metrics definitely give you an aggregated overview of how your system is behaving at a given time. But more often than not, when you have to dig deeper, you probably end up trying to see, hey, was there exceptions in the log, or you may have some debug message like, when this happens, log that thing. You may want to log the queries that you are getting to see, to understand if this was a low selectivity query or the response of the queries and so on, right? Having those logs be discoverable, searchable for debuggability purposes is also something that really helps a lot. I've seen folks use, in the past, Elk was the system people used to use. Now I see Datadog as being a lot more, in that, not just for logs, but also for performance metrics and so on. So those systems definitely help.
Makes sense. One common thing, I'm just being curious here because I've seen this happening. So there are metrics that have these tags, for example, and they have like high cardinality, so they can create like thousands and thousands of variants of the same metric, right? So how do we usually do that? Like in your experience, do we just group them into larger buckets, or how do we do it? So for example, let's say if I add like a customer ID in my metric, right? So that is a high cardinality, and that might blow up the metric system and add a lot of cost to my observability part. So how do we do that? How do we usually monitor that?
Yeah, I mean, if you have I think aggregation is the key there. Mm-hmm. Probably you want to kind of like say on average, or on an aggregated view, how that particular metric is doing, right? One typical example could be the following, right? So let's say I have a multi-tenant cluster where I am hosting n number of tables that are being by the entire cluster, and then one server is down or slow. I log on to I look at the dashboard for that server. I may see like thousands of tables if it's hosting those, or I may just aggregate across all and say, well, yeah, the latency spikes only on this server, and then just go look at it. But sometimes it is useful, because once you found the problematic server, then you may want to see like, okay, which table was that, which had an issue, right? So, it's a case by case kind of,
I agree. And that's when you want to dig deeper, metrics might not be the right place, but logs are a better place, because definitely. You can log more. Great. Sounds good. So I think we have covered 3 stages, like development, the CI/CD or the release pipeline, and the observability part, like after things are deployed. How about maintaining it, right? What happens when things go wrong, and how do we mitigate those things?
Exactly. Yeah. So operability and tooling is a key factor. And I would say it starts right from, onboarding of a new use case all the way up until, when things go wrong, right? And everything in between. And all of these should be as self-serve as possible, or at least have enough automation that you avoid all the manual process every time, for example, right? For stateful systems, you want to onboard a new use case onto it. The first thing is like, okay, let's say I want to create a dedicated cluster for this. So what should the cluster look like? What kind of, nodes I need? Right? If there is a indexing scheme that I need to use specifically in case of Pinot, what should it look like? And those kind of things, right? So the initial provisioning, capacity planning, all these things should be, as automated as possible. Now, obviously, a lot of these are like, hard problems to solve, because without, the most accurate way to know about a workload is to actually run the workload. Before that, it is like, English-like description, which may lose a lot of details, right? From the user who's trying to kind of use. They may say, like, oh yeah, it's a given that we will do a group by on high cardinality, for example, right? But you don't know that because it's not there. So based on the best that you know, how you capacity plan it, how you actually provision it. And when we're talking about provisioning, we're talking about take this requirements and actually, maybe like click a button and that cluster gets deployed to your specification, for example, right? And the reverse says, okay, now you want to tear down because the use case no longer is needed. So decommissioning should also be self-serve, right? So operations around that, to begin with, right? That's a given. Scaling up and down is yet another thing that happens once you start, operating the service. Is like a lot of times, depending on the need of and the workload increase, or the maybe new tenants coming in, you may want to add more servers and so on. So that should also be automated.
That makes sense. So I think there are 2 interesting things here. Like one is the capacity planning, where you want to know like beforehand how much capacity you're going to need. For example, I'm working for an e-commerce company, and I know that, okay, Black Friday is a big event, I'm going to process like thousands of orders per minute and earn millions of dollars. So how do I plan for that kind of capacity, right? So that comes in pre-scaling, and how load testing or performance testing can actually give me that magic number.
Yeah. I mean, it's a great question, right? And for systems that sustain or catering to variable workloads, it's kind of challenging to statically, come up with a number, right?
Yeah.
Because there's so many things that happen when the actual workload comes in. So figuring out like a model that works for your system, like most of the time, if not all the time, like, say, okay, if I have 32 cores and 64 gigs at my disposal as a single node, and can have many of those, I know that the best performance I can get out of it is 1,000 read requests, say, for example, right? Per second, and, maybe 100K or 10K write requests or something like that. So if you know that, what's the capacity of a single node, and then you can like make some empirical formula or calculations, right? But the more accurate you want to be, the more you end up being kind of like going into that mode of shadowing, which is where our performance benchmarking right, or building up the cluster. So one design pattern that I have seen specifically for your case is to kind of have a separate cluster up and running and run synthetic load on it, which is mimicking your the Black Friday. I mean, if you don't have any data points, that's what you would do. A lot of times you would just learn from the previous Black Friday, saying, okay, last year we needed 100 nodes. Maybe this year, just to be on the safer side, 200 nodes, something like that. So those are some of the ideas
makes
to look
sense.
at.
Yeah. I think it makes sense, and I've seen it being used a lot of times. Like also the shadow environment, but it's tricky because mimicking the production environment is tricky because production environment has like hundreds of different factors that can impact different things. But it's always best to be as close as the production environment. Great. How does so since we are talking about scaling up and scaling down, I'm just curious how serverless model comes into this piece of our section where we are want to scale up very quickly depending on the traffic pattern. I guess Pinot also supports serverless like as a cloud offering. And how does that work? I'm always curious to understand, with stateful.
So scaling, right. So in stateful systems, again, this is, there's a lot of things to take care of and think about when you want to do scaling up and down. Primarily in terms of, the data redistribution or not, right? Like, do you need to move a lot of data around it, right? So let's say you have X terabytes of data in Y number of nodes. You added a few more nodes. Do you need to redistribute all your data? How much is the data movement? Because that's going to impact the traffic that is being served around that time, right? What we have tried is, made Pinot horizontally scalable for read throughput by saying, okay, there is one copy of data which is in, let's say, K servers, right? And it gives us 1,000 queries per second as a read. Then I can add another copy and I can get 2,000, another copy 3,000, and so on, right? So you scale it horizontally. And in this case, because you're bringing up one replica with the entire data content, the redistribution doesn't necessarily doesn't need to happen at all, right? So you scale it up and scale it down based on replica sets. That's one way to kind of avoid. But there are certain scenarios where you cannot avoid the redistribution of data when, let's say your replica set is not big enough and you want to add more nodes to that, right? So, I mean, you have to think about that. In Pinot specifically, the algorithm to rebalance the data on our different server number of nodes is smart enough to minimize the data movement, right? But at the same time, the state management is such that even if a server has to, let's say, load 1,000 shards before it can actually, come fully online, the requests to it will only be given for the shards that are already available for serving. Right. So it's not like the query comes in and then it needs to load the shard. So that's the cold start to that part of the cold start is not there. Right. So we try to avoid those things.
Yeah. I think it makes sense. And I think that is a great point. What happens? So since we are talking about scaling, let's also talk a little bit more on scaling down. So let's say Black Friday is over and I want to scale down. For stateful systems, right, there will be a limit, right, how much you can scale down, because you have to serve that data, and one machine or less machines may not be able to survive that much load. So how does that work, and what kind of practices do we follow to make sure this does not happen?
I mean, if you take the example of the replica set horizontal scaling that I just described, right? So we kind of know like what's the throughput we're going to get per replica set, and you either add more or reduce, right? So, I mean, that particular case or use case is much simpler than when you may have to kind of change the replica set itself, right? And those need to be done more in a controlled environment, like, and also, again, done with the knowledge of the workload itself. So, especially if you have very tight SLAs that you are guaranteeing, right?
Makes sense. Cool. Let's talk a little bit on, the failure side. Like, what happens when things go wrong? When servers are failing, when like the complete AZ is down or regions are down, what happens then?
Yeah, so disaster recovery is definitely, something that you want to think about when, building your system, right? Like, what are the different ways to do per disaster recovery, right? So within an AZ, right, or a region, what you can do, we don't do that today, or at least we do that in certain deployments, and not all is within. If you are like, fault domain aware, for example, right, or power domain aware in your data center, then you can make sure that the replicas are not on the same fault domain, for example. Right? That's one. But for disaster recovery, I think the pattern is have your data as well as meta. So every data system will have the data that needs to host, and also the metadata, which is the state of the system, right? These two should be kind of like durable as much as possible, right? And if you want to distribute it across different geographies, I think that's one way to do it. But at the same time, you want to be able to say that, hey, even if my entire cluster goes down, as long as I have pointer to the data and the metadata, I can resurrect the cluster back up, right? So build that capability in your system to be able to, looking at the data and metadata, the entire cluster can come up and resurrect that state. Right?
Makes sense.
Patterns that I have seen for disaster recovery, again, is, having clusters which are air gapped and running in different regions, for example, right? And maybe they are serving traffic independently. The data in these two are kind of synchronized either internally through some sync mechanism or externally through the ingestion pipelines, right? And you use this for not just for having affinity to the geography for your read requests coming in, a certain region, go to this one, certain other region, you can go to that one. But then you can also use this as I want to do if you're not on cloud, maybe you're in a data center and you want to do some maintenance on the data center, you can, bring this down, shift the traffic to the other one, maintain it, bring it back up, and so on. Right? So those kind of things I've seen as some of the solutions out there.
I think it sounds good. So I think the thumb rule is, it's best to know what kind of failure modes you want to support and design your system around that, right? And like when things go wrong, there's no time to design and do all those mitigation steps that we just talked about. So it's best to move this, at least the thought process, right from the development phase, like how you want to design your system. So all these the replication or the cross data center fault tolerance and all that is kind of baked in the distributed system and not like as an afterthought.
Yep.
Cool. Sounds good. So I think now let's say our system is like fault tolerant, but still there can be some failures happening and people are getting paged. What kind of processes do we follow to make sure that the process itself of debugging and finding the root cause and then improving so that it doesn't happen again? How do we make sure we do that correctly?
Right. So I personally feel that this is like a feedback loop, which is kind of, it has to go inside into the from the development cycle all the way to the field or the deployment and then back, right? And so we already talked about alerting, monitoring, observability, supportability, and all those things. So as long as you have those things, you are able to kind of at least mitigate a production issue immediately. But a lot of times, what I've seen happens on the ground is you solve a production issue and you feel really happy. Like, okay, everybody claps, right? Hey, we solved this. It happens, or a different issue happens, and you feel really happy. And before you know it, you are kind of in a what I call it is like a superhero syndrome. When, okay, there's a fire, I'll put it off, right? But I think this is the time where you need to take a step back and say, am I spending too much time in certain things, which manually, which could be automated, right? That's the first thing, right? We know there is a pattern of these things that are happening. So that feedback that has to be gathered, and the software itself has to be improved based on that. And your goal should be to kind of like make the system as autopilot as possible, physically speaking, right? So that's the idea. The process to follow that is like all the incidents, you want to do a root cause analysis. You want to do a postmortem, understand what are all the things that went wrong, right? And what are the things they may translate into, some of them into, some improvement in the code, some improvement in algorithm, improvement in, the observability. Every part of the system that we discuss may actually have some feedback from here. And it is really important to gather this and improve, right? So it's like, both parts of the system or the ecosystem feeding on each other, right? The development cycle is kind of making sure that it's not just the software is good, but it's also, observability, supportability, and so on. But this part of the system is actually giving feedback on how we can make it even better, right? We're talking not just in terms of function and performance, but also in terms of the other factors or categories.
Yeah. I think it makes sense. So this feedback loop is critical because that's how you achieve like operational excellence. If you're not learning from your mistakes and you're kind of repeating the same things, you're not having automation, you're letting your engineers do all those manual processes, that it's not going to help. It's going to be tiring. And I think that's another reason why on-call becomes like such a painful thing, that there is no process, there's no automation.
It becomes very dreadful very quickly, right? That's one issue. The other phenomenon I've seen is like, it slowly starts eating up your development, time, right? So you end up being more and more, and before you know it, you end up being in this firefighting mode all the time, or keeping the lights on all the time. And versus you could be using the same time to, build new features and, expand your system, right? In terms of its capabilities.
Nice. Let's talk a little bit more on the on-call process. Like what have you seen, works really nicely when it comes to on-call process, and, how to make sure we are getting better at it?
Yeah. So typically, again, we start from we start from like an initial state of the system wherein we say, okay, here are the things that we anticipate can go wrong. And there's mitigation steps here. So, very crisp runbooks. And this is, of course, on top of what we already discussed in terms of the observability and all those things, right? So having very crisp runbooks to kind of like triage the issue, mitigate the issue, and then once you've done that, follow the process to get the feedback back, right?
Yeah, makes sense. So basically, it's important that, as an on-call engineer, whenever I get paged, first of all, I must have all these, observability into my system, so I know where to look at and how to find the root cause. And then I need these runbooks to, figure out what steps do I need to do to solve this problem and to reduce the impact. And then I am also responsible for, giving it back to the the development cycle, so I can improve that and stop it happening in the future again. So talking about runbooks, right? I've seen this issue that runbooks are like mostly outdated, right? Because there is so much deadline, there's so much pressure, on-call noise, and all that. So what in your experience, what kind of strategy works best to keep those updated?
Yeah, you're definitely right. These go out of sync pretty fast, right? And the only way to kind of, again, it goes back to people, process, and technology, right? So there's a process part. You can set up the process saying that every on-call, if you followed a run book and something didn't work well, or you have a feedback, you must update it right away, right? That's the process part. But the people part is like the people have to follow the process. And so, as a team, as long as the team understands that, these are things that are important to work as a very efficient, a high productive team, then yes, I think that the culture and the mindset is also equally important.
Yeah, I think it makes sense. So I think the mindset that, okay, I'm on call for a week, and then after this week is done, it's someone else's responsibility, is not going to work. No. If you get paged, you have this full responsibility to feed that back into the system so it's improved, and then also update the run book if it's not up to date. So I think it boils down to one's responsibility, and great. I think it makes a lot of sense, and I guess we have covered a lot of insights, right? Like from the beginning to the end and the entire life cycle on how to develop, how to release, how to monitor, and how to operate a distributed system, and that too like a stateful distributed system, which is like a really hard problem. I mean, like there are companies who are doing that at scale like a pro, like Startree, but I'm pretty sure like our viewers after watching this episode are going to at least learn like some insights and some practices that they can follow in their companies or their pipelines to make their overall process better. So thank you so much for sharing all those insights. I'm pretty sure I learned a lot, and I'm going to implement those in my systems, and I'm pretty sure our viewers will also enjoy watching this episode. So to our viewers, if you like this episode, if you enjoyed this, please hit that like button and subscribe to the YouTube channel so I can create more and more such content. And so thank you so much, Mayank, for sharing all the details. I'm looking forward to collaborate with you more in future.
Same here. Thank you for having me.
Thank you.